Hi students, we have already learned linear equations in two variables. Now we will learn how to apply linear equations in two variables to word problems. Before we go to the questions, the two questions that I am going to discuss in this video will require you to know the relation between distance, time and speed. So let us first revise the formula. Now to know the formula, you just need to remember this triangle. Just remember DST, D at the top, S and T at the bottom. You can just remember it as rhyming of GST. Just in place of G you have to put D. GST you will keep hearing very often, so it is something that you won't forget it. So DST, D for distance, S for speed and T for time. Now you need to find out any of the three quantities, just cover that particular quantity. So let's say I want to find out distance, or in this case let's first take speed. So if I want to find out speed, I will just cover speed. The remaining two quantities are distance and time. So that is speed is distance upon time, because D is at the top, T is at the bottom. Similarly, if I want to find out time, just cover T, the remaining two quantities, D at the top, speed at the bottom. So distance upon speed. Now if I want to find out distance, just cover distance, and the remaining two quantities both are at the bottom. So I will just multiply them, that is speed into time. And that was easy. You can just draw this triangle somewhere in your answer sheet. When you get the first thing in the rough work, you can draw it so that you don't forget it, and you can use it in any question that requires distance, time and speed formula. So now let's head over to the questions. Now this is question 6 from practice set 1.5. Out of 1900 kilometers, Vishal traveled some distance by bus and some by aeroplane. The bus travels with an average speed of 60 km per hour and the average speed of aeroplane is 700 km per hour. It takes 5 hours to complete the journey. Find the distance Vishal traveled by bus. Now, as in any word problem, the last sentence of the word problem gives you the hint as to how you will start the question. Now here they have asked you to find the distance Vishal traveled by bus. So that will be our first variable. Let the distance traveled by bus be x kilometers. Now we need to consider the other variable, that is the distance traveled by aeroplane, which will be y kilometers. Now the quantities which are given in the question is the speed and the distance. So probably will be, and we have assumed the distance to be x and y. So let's say we know the distance x and the speed, corresponding speed by bus. So we will be adding up the times, which will give us total time taken by the journey, that is 5 hours. Also we know the total distance, that is x plus y. So the total distance is 1900 kilometers, so x plus y is equal to 1900. This is my first equation. Now, like I said earlier, we'll be using time equal to distance upon speed. So now the individual times by the bus journey and the plane journey, the time taken by the bus journey at speed of 60 kilometers per hour, that is distance x upon speed 60, and time taken for the airplane journey, that is 700 kilometers per hour is the speed, so y upon 700. The total time taken for this journey is 5 hours. So hence now our equation from this information will be x by 60 plus y by 700, that is equal to 5. We need to simplify this equation further because we have denominators 60 and 700, which will have to be dealt at some point any method you use. So let us first get rid of these denominators now itself. So multiply throughout by the LCM of 60 and 700, which is 2100. So when we multiply the whole equation by this number, we get 35x plus 3y equal to 10,500. Now we have got our two equations. We can just solve these two equations by any method. So I'll use the equating of coefficients method. So I'll multiply equation 1 to get 3y in that equation. So I'll multiply it by 3, thereby giving me 3x plus 3y, which is equal to 5700. Now this is my third equation. I'll subtract equation 2 from equation 3, which cancels out the y term, giving 32x equal to 4800. And on further simplification, I get my value of x, which is the distance traveled by bus. Now please note, in the question they have not asked us the distance traveled by aeroplane. So I need not substitute this value of x in any equation to obtain value of y, because that is not asked. So I conclude by my final answer, that is the distance traveled by Vishal by bus is 150 kilometers. Now this is another question from problem set 1. Places A and B are 30 kilometers apart and they are on a straight road. Hamid travels from A to B on bike. At the same time, Joseph starts from B on bike, travel towards A. They meet each other after 20 minutes. If Joseph would have started from B at the same time but in the opposite direction instead of A, Hamid would have caught him after 3 hours. Find the speed of Hamid and Joseph. Now before we go down to the solution, let us try to visualize this problem. A and B are two places which are 30 kilometers apart. Now in first case, Hamid travels from A to B and Joseph from B to A. They meet each other after 20 minutes. In the second case, Joseph is traveling away from A in the other direction. They still meet each other after 3 hours. That is because Hamid would have caught him, his speed being higher. Find the speed of Hamid and Joseph. So like always, the last sentence gives us the hint to the first statement of your solution. Find the speed of Hamid and Joseph. So I will assume the speed of Hamid to be x kilometers per hour and Joseph to be y kilometers per hour. Here we use the formula distance is speed into time. So we'll be calculating the individual distances covered by Hamid and Joseph, taking into account the speed which is x kilometers per hour and y kilometers per hour respectively. And when they travel towards each other, they meet each other after 20 minutes. The time taken by them to meet each other, that is 20 minutes, getting converted into hours, that is 1/3 hours. So this is the time, we have the speed, so now we can calculate the distance traveled by each of them. The distance traveled by Hamid is x into 1/3, which is x/3. Distance traveled by Joseph is y into 1/3. Now as is evident in the diagram, the total distance traveled by them will be 30 kilometers. So my first equation is x/3 plus y by 30. Simplifying this further, I get x plus y equal to 90. This is by multiplying the equation throughout by 3. In the second case, that is when Hamid and Joseph travel in the same direction away from A, they meet each other after 3 hours because Hamid's speed is greater. So now the time taken by them to meet each other is 3 hours. The same formula, that is distance is speed into time. Now here the distance traveled by Hamid will be more, that is 3x, x into 3, 3x. Distance traveled by Joseph is y into 3, that is 3y. Now as you can see in the diagram, the distance traveled by Hamid is more than that of Joseph. So we can take the difference, this difference will be 30 kilometers. So 3x minus 3y equal to 30, dividing throughout by 3 gives us x minus y equal to 10. This is our second equation, and now all we need to do is just add the two equations. It is equation 1, x plus y equal to 90, and equation 2, thereby giving us 2x equal to 100, and solving for x gives us x equal to 50. And substituting this value of x in equation 1, we get y equal to 40. So now we have our speeds. That is our final answer. Hamid's speed is 50 kilometers per hour and Joseph's speed is 40 kilometers per hour.